Good morning, dragons. It's Question Tuesday, the day I answer real questions from real dragons. Let's get right to it. So I had a ton of second graders ask me about magnets this week, and I'm going to talk about them really briefly. I had Micah and Jonas and Harrison and Ledger and Andrew and Carly and Bentley and Pratam and a couple of questions that didn't even have names on them. I love it. I love that you guys are so excited about this. So we had some really good questions. We had, what are magnets made of? How are magnets magnetic? How do you make one? And then how they pick up tiny magnets, which I think the questioner was talking about the iron filings we've been using in class, which is a really good question. So we're going to talk about magnets really briefly right here at the beginning. So magnets are made of iron, always. Sometimes it's a substance that's got iron in it, but the iron is what makes it magnetic. So how a magnet works is that iron gets just the tiniest bit of an electrical charge, which realigns the molecules, the tiny pieces it's made of, and puts them in a straight line. All of the positive ends pointing that way, all of the negative ends pointing that way, and creates this teeny tiny electrical field we call a magnetic field, which is why it attracts other things made of iron, because it's really easy to make those molecules align that way in iron. And the reason it picks up the iron filings is because those are teeny tiny pieces of iron. And why it's easier to pick those up than other things is because iron filings are so tiny. They're really light and they're pure iron. So the whole thing is going to be attracted to a magnet, and it's little, so it jumps right off that table because it doesn't have enough weight to keep it down. I had another really good question about magnets. Cash asked me, if a nail is attracted to a magnet and a washer is attracted to a magnet, why aren't the nail and the washer attracted to each other? And Cash, that is such a good question, because sometimes they are. Here's how it works, Cash. That washer and that nail are not magnetically charged. They have no magnetic field of their own, so they don't attract each other. But if you leave them next to a magnet for long enough, you make them into a magnet, which is part of how magnets are made, and then they will be slightly attracted to each other. But that's not the best way to make a magnet. The best way to make a magnet is to run some electricity through it. And that's kind of hard to do at home. But here's something you can do at home. If you take a needle and you rub it with cloth in the same direction for a good long time, it'll be slightly magnetic. It'll be just magnetic enough that if you can very carefully float it on something in a bowl of water, it will spin like a compass to point toward the magnetic north of the Earth. Definitely try that at home. We had a lot of other good questions too, though. We had Daniel wanting to know why pumpkins rot. Daniel, great question, and perfect for this time of year, because I imagine everybody's Halloween pumpkins are starting to get a little rotted by now. Daniel, the reason this happens is because there are microorganisms, little teeny tiny animals, that are in charge of breaking down all of the waste in the world. It's part of how our ecosystem works. Now, when they get into a pumpkin, just like anything else they get into, they break it down. They start that process of decomposition that we started learning about in first grade and turning it into good, rich soil for new things to grow in. But you might be wondering why carved pumpkins always decompose so much faster than pumpkins that are not carved. Pumpkins develop this kind of survival mechanism so that they will move their seeds far away from the plant, just like a lot of fruits have that skin on the outside. I know a lot of you like to eat apples, and if you've ever peeled an apple, you're peeling off that outside skin that keeps the inside fruit safe. Well, a pumpkin works the same way. It's got an outside waxy skin that protects that kind of gooey pumpkin guts in the middle. Those pumpkin guts, because they are wet and usually a little bit warm, are the perfect place for those microorganisms to live. They like wet, warm places. Now, when we carve a pumpkin, we expose those wet, warm insides to the air outside where the microorganisms live. And it makes it a lot easier for them to get inside and start breaking the pumpkin down. Such a good question, Daniel. I love it. Audrey wants to know why when birds land on power lines, they don't get electrocuted. Now, Audrey, I thought I knew the answer to this, but I did a little research and it turns out I was totally wrong. It's a really cool thing. So, Audrey, those electrical wires are made out of copper, something that is very, very conductive, something that electricity goes through really, really easily. Now, they're at a constant voltage, they're at a constant strength, that electricity that goes through those copper wires really easily. And when a bird lands on it, birds are not as good of a conductor as the copper wire. It's harder for electricity to move through them. And like we talked about in our last question Tuesday, electricity always chooses the easiest way to go. So when it has the option between copper wire, where it's really easy, and a bird where it's not, it'll stay in that copper wire. But if the bird disrupts the balance, if it touches something with a different electrical charge, like another power line, zap, that bird's going to be fried. That's a really interesting question, Audrey, and I'm so glad you asked it because I got to learn something new too. Daniel had another question about pufferfish that I thought was really interesting. Daniel wants to know why pufferfish puff up. Such a good question, Daniel. Pufferfish puff up because they fill with water when a predator swims by. It's their defense mechanism. It makes them look bigger and more terrifying. And just like Jellybean the hedgehog will huff and huff so that her spikes stick out, when a pufferfish blows up with water, its spikes stick out more. So it looks big and scary and spiky, and it's less likely to be eaten. Such a good question, Daniel. Tristan wants to know what happens when you put foil in fire. Tristan, I have kind of a disappointing answer for you because the answer is not much. Foil is a metal, so most of what happens is it gets really hot. Most fires aren't really hot enough to do any damage to the foil either, so it just gets hot. But if you put foil in a microwave, something very different happens. What happens is it builds up static electricity until it discharges, like a strike of lightning. And if you've never thought about lightning in a microwave before, yeah, that could do a lot of damage. Don't try that one at home, Tristan, but it was a really good question. Sawyer wants to know about the speed of lightning, and Sawyer, I have so many numbers to share with you. Sawyer, lightning itself is 300 million volts, so much more than the copper wires we talked about earlier, but it's only about an inch or two wide. That's only about that wide. So tiny and so much electricity going so fast because Sawyer, lightning strikes down, but then it immediately strikes back up. Because what lightning is the clouds in the air build up and build up a negative charge, right? They build up a negative charge in those clouds, and the earth builds up a positive charge. And then those charges want to connect. That's what lightning is. It's that connection of electricity. So it strikes down, and then the ground strikes back up at the clouds, usually 3 or 4 times, really, really fast. Striking down, it goes 320,000 feet per second. That's 220,000 miles per hour. And then going back up, 320 million feet per second, 220 million miles per hour. It's crazy. Now, compared to that, thunder travels at 1,100 feet per second, 750 miles per hour. Much, much slower, which is why you always see that lightning flickering flash before you hear thunder. Really interesting question, Sawyer. I'm glad you asked it because, again, I got to learn something new. And then Hallie wants to know why mirrors reflect light. I love it, Hallie, and I love that it relates to what we were doing in class. So mirrors are made of a layer of glass, a layer of something shiny, usually either silver or polished aluminum, and then a black back. That's why when you look at a mirror, it kind of looks a shiny silver on one side and a dull black on the other. I know we've talked about this when we talked about colors and being able to see colors, that when white light hits something, it reflects back a color. Now, most things light hits, like me, it will just kind of scatter and go everywhere. And the parts that hit your eyes are what you see. But when light hits a mirror, because it is such a shiny, smooth surface under that glass and on top of that black surface, the light hits and bounces back in a pretty straight line, which is why you can see your reflection in things that are smooth and shiny. Not just in mirrors, but you can see them in spoons and bowls and anything smooth and shiny, a car. Anything like that, you can see your reflection. Really good question, Hallie. I'm so glad you guys asked all these amazing science questions. And I did want to let you know that I got all of your really cool other questions as well about me and about how I write lessons. So next week over the Thanksgiving break, we will still have Question Tuesday, and it will be special Thanksgiving Miss B edition of Question Tuesday. I really think it's amazing that you guys wanted to know about me and my life. And it makes me feel really special. So I love you guys, and I'll see you in class. Bye, dragons.